Hello and welcome to video number 16 in this series. And in this video I'll begin to review solving equations, starting with linear equations. So I'll define a linear equation in one variable in the following way: ax plus b equals 0. And here a and b are real numbers, and a is not equal to 0, and x is our variable here. And so what it means to solve this equation for x means I'm trying to find the value of x that will make both sides of this equation equal to one another. And another way of framing that is to say I want to find the root of this equation. And for an equation like this, there's only a single value of x that satisfies this equation. There's only one root. So as an example, let's do 2x minus 6 equals 0. So if I want to solve that equation, I'm wanting to isolate x on one side of the equation so that there's only numbers that we can evaluate on the other side of the equation. And we talked about that in an earlier video, and we have two basic strategies for doing that. We can add a number to both sides of the equation, or we can multiply both sides of the equation by a number. So let's employ both those strategies to solve this equation. So first of all, remember I'm trying to get x on one side and just numbers on the other side. So I can see on the left-hand side I've got a minus 6. So if I add 6 to both sides of the equation, then that will cancel this minus 6 on the left-hand side, and I'll be moving a number to the right-hand side but leaving the part of the expression involving x on the left-hand side. So let's do that first. So now the minus 6 and the plus 6 cancel, and I've got 2x equals 6. And then now, if I multiply both sides of the equation by a half, now the half times 2 will cancel to become 1 times x, so just x, and we have our solution x equals a half times 6, or 3. Anytime you solve an equation like this, check your answer by taking your solution and plugging it back into your original equation. So we're going to check that 2 times 3 minus 6 does indeed equal 0. 2 times 3 is 6, 6 minus 6 is 0. So a linear equation of this form only has one solution, as I say. So in this example it was x equals 3, and we can see this if we draw a graph of what this function looks like. So if I set up some axes, so my horizontal axis represents x, and then the vertical axis represents this equation here. And so one way to think about this is to write the vertical axis as y, and then I'm going to graph the function, or the equation, y equals 2x minus 6. So that's going to cross this vertical axis at minus 6, because when x is 0, y is going to be minus 6. And it'll cross the x-axis at the value we just found, x equals 3. And then we can draw a line passing through these 2 points, a nice straight line, and that's going to represent the function y equals 2x minus 6. And where this line crosses the x-axis, the horizontal axis, is the solution to the equation that we started with, 2x minus 6 equals 0. We're finding which value of x results in a value of y equals 0. And the answer is an x equals 3 results in a y of 0. So let's do a couple more examples. So let's solve 3x minus 4 equals 8. So the form of this example is a little bit different to the earlier form because I don't have 0 on this side. But this is equivalent to, if I wanted to make 0 on this side, it's equivalent to, if I subtract 8 from both sides, I could have 3x minus 12 equal 0. But I'm going to start with this expression instead. So first thing I want to do is I want to kind of get rid of the minus 4. So I'll add 4 to both sides. And this time I'm not going to kind of write all the steps. I'm going to compress the amount that I'm writing just to save a little bit of time. So if I add 4 to both sides, that will cancel on the left-hand side and just add 4 to the right-hand side. So I'll have 3x equals, and then 8 plus 4 is 12. And then if I divide both sides by 3, I have x equals 12 over 3, or 4. And then, again, I want to check that my answer works. So I need to check that 3 times 4 minus 4 does equal 8. And 3 times 4 is 12. 12 minus 4 is 8. So it does work out. And let's do one more example. Let's do an example involving fraction. So let's do minus 5 over 4 times x plus 2 equals minus 3. So I'll deal with the plus 2 first by subtracting 2 from both sides. So I'll have minus 3 minus 2 on the right-hand side. And then I'm going to multiply both sides by minus 4 over 5. Because minus 4 over 5 times minus 5 over 4 would be equal to 1. So I'll just have x on the left-hand side. And I'm just going to write this one out because sometimes fractions, it's easy to make mistakes. So I got minus 4 over 5 times, I'll use a dot, times 5. And so here my 5s are going to cancel, and I'll be left with x equal minus 4, which is not right. Did I do? Oh, it's because I got a minus. I do have a minus. I do have a minus. So we're fine. Okay. So just rewind, and so we end up with the minus 4, and again, just check that it's correct. So we'll plug in minus 4 into our original equation. So minus 5 over 4 times minus 4 plus 2. And we want that to equal minus 3. So minus 5 over 4 times minus 4 would be plus, no. What am I doing? No, plus, oh my God. Yeah, no, I'm doing something wrong.
So just,
Oh, it's because I got a minus here. Yeah. Jesus. Jesus.
I say it's going there.
Okay, so we've got to go back to that part. So next, I need to isolate the x on the left-hand side by multiplying both sides of this equation by minus 4 over 5. So the minus 4 over 5 times minus 5 over 4 would become 1. So I've just got 1 times x on the left-hand side. And then on the right-hand side, I've got minus 4 over 5 times minus 5. And so the 5's cancel. And I just have to be careful with my negative signs. I've got negative 4 and then a negative here. So that's going to become positive 4. And so I then just need to check that that works. So I've got minus 5 over 4 times 4 plus 2. So minus 5 over 4 times 4 is minus 5. Minus 5 plus 2 is minus 3. So everything's good. So another way in which we can use linear equations like this and try and find a value of x that satisfies some linear equations is if we have two linear equations and we're trying to find the value of x that makes the two equations equal to one another. So for example, if I have the linear equation plus 2x minus 3 and then minus 3x plus 7. And what I'm going to do actually is I'm going to call this one y1 and then this one y2. So I've got two equations here. And we could think of these as representing two lines on a graph. So, for example, this first line is going to cross the y-axis at y equals minus 3. And then it's going to have a positive slope because the slope is given by this number here, the plus 2. And so it's going to go kind of up this way. And then, so this is y1, the y1 equation. And then the y2 equation is going to be negatively sloped with a slope of minus 3. And it's going to cross at, maybe I'll just make this go up a little higher, at 7, y equals 7. And it's going to come down kind of like this. And what I'm trying to find is I'm trying to find that point there. So which value of x would make both of these linear equations equal to one another? And while we're at it, we'll find the value of y as well. And we call that x0 and y0. So to do that, all I do is set these equations equal to one another. So 2x minus 3 equals minus 3x plus 7. And then what I'm wanting to do is I'm wanting to have x isolated on one side of the equation and just numbers on the other side. So first thing I could do here is to get the x's all on this side, I could add 3x to both sides. If I add 3x to the right-hand side, it's going to cancel the minus 3x here. And then if I add 3x to this side, I'll have 5x. And over here, I won't have any x's. And then in terms of the numbers, the 7 and the minus 3, I want to move this minus 3 over here. So if I add 3, that would cancel it over here and add 3 to this side. So I've already got 7 here, so now I've got 7 plus 3, which is 10. And then the last step, if I just divide both sides by 5, I'm going to have x equal 2. Let's check that we got the right answer. So the way to check this is to plug in x equals 2 into both of our equations and make sure we get the same value of y. So let's do the first one. So 2 times 2 minus 3 would be 4 minus 3 would be 1. And then the other equation, minus 3 times 2 plus 7. Minus 3 times 2 is minus 6. And plus 7 would be 1. So this value on my graph is 1, and this one here is 2. So the two equations cross when x is 2 and y is 1. So at this point, pause the video, and I'm going to give you a couple of problems to work on and see if you can work through and get the correct answers. So the first one is going to be kind of more with this kind of flavor. So let's solve this equation for x. So solve for x, and we're going to have minus 2x plus 3 equals 1. So find the value of x that makes both sides of this equation equal to each other. And then the other one, we're going to have two equations for x. So it's going to be more like this example. We'll have, let's see, 5 over 3 x minus 9. And we want that to be equal to minus 2x plus 2. And then remember, once you've got your solutions, to check them by plugging in the value that you obtain into the equations to make sure that they work. So let's go through the first example, first problem. So we've got minus 2x plus 3 equals 1. I want to isolate x on one side of the equation. So let's subtract 3 from both sides first. So if we subtract 3 here, it will cancel with the plus 3. And we've got 1 minus 3, so we'll have minus 2. And then if we divide both sides by minus 2, we have x on the left-hand side, and on the right-hand side, minus 2 divided by minus 2 is 1. And then let's check. So we'll plug in the value x equals 1 into our equation. And minus 2 times 1 is minus 2. Minus 2 plus 3 is plus 1, which is what we were hoping it would be, so that's okay. And then the second problem, so we got 5/3 of x minus 9 equals minus 2x plus 2. So I'll try and get all the x's on the left-hand side. So we'll do add 2x to both sides. So we'll have 5/3 x plus 2x. So that will get rid of the x on this side. And then to get rid of the minus 9 on this side, we'll add 9 to both sides of the equation. So we'll have 2 plus 9. So now I need to add 5/3 and 2. So a common denominator there would be thirds. And so 2, if I want that to be in thirds, I need 6/3 would be 2. So I got 6/3 here and 5/3 here. So I got 11/3 of x. And over on this side I've got 11. And then if I multiply both sides by 3 over 11, then we'll end up with x equal 3. And checking that that's the right answer. So in my first equation, 5 over 3 times 3 minus 9. So 5 over 3 times 3 is 5. 5 minus 9 is minus 4. And my other equation, minus 2 times 3 plus 2. So minus 2 times 3 is minus 6, and plus 2 is minus 4. So they're the same, so that checks out as well. So that's it for this video, and in the next video we're going to turn our attention to quadratic equations and look at solving those equations by factoring.